So I'm going to say we're going to talk a little bit about impacts. We'll talk more about impacts later in the semester after we talk about Earth a little bit, and we'll talk about Earth's terrestrial interaction. Uh, but on this list, notice the one at the very top. It impacted October 7th of 2008. And so the Catalina Sky Survey on October 6th, late in the afternoon, late in the day, discovered a object which they calculated would just impact a few hours later. So they could tell it was going to impact somewhere in northern Africa, and that's really all they could find about it. And so the exact, they didn't have enough measurements to do an exact calculation. Initial measurements indicated it was only about 2 meters in diameter. That's big enough to make an atomic bomb-sized explosion, but it wouldn't do absolute devastation to a huge area of a country, just people right under it. And so now, the problem is, even if they could calculate exactly where this thing was coming, there's not much you can do. So what if we're heading right for a major city? What do? Well, you cannot evacuate. A number of years ago, there was a hurricane that, of course, you had Hurricane Katrina that went into New Orleans. And so people immediately became hypersensitive as to how bad hurricanes could be. And so later that year, there was a hurricane that was headed towards Houston, Hurricane Rita. And so as that hurricane started headed towards Houston, a lot of people decided to evacuate beyond just the people in the coast. And it was total gridlock going out of Houston. More people actually died in the traffic than they did in from the hurricane. There was like a bus that caught fire full of elderly people. There were people who had heart attacks. Ambulances couldn't get to them, so because of the gridlock. So and it took days to clear everything out. So there's no way, if there's just a few hours, you can actually evacuate, and get everybody out. And so that's not going to happen. So unless people actually had some kind of shelter at home, then there's not a lot that you can do. It impacted at about 13 kilometers per second in the northern Sudan, and was actually equivalent to about 2 kilotons in TNT. So that's like a small atomic bomb. So that's considerably smaller than the Hiroshima event, but roughly about 1/6 or 1/7 of the Hiroshima event bomb. The airline, it was an aircraft about almost 1,000 miles away, saw the flash, and a weather satellite picked up the flash from the impact. So that impact we saw just hours ahead of time. Another one here was discovered in 2014 and was impacted just a few hours later, the very next day. And they knew it was going to impact somewhere along that line near the equator, actually north of the equator, so along that line right there that's marked on the picture. And so what they did was they were able to find out it was going to be somewhere along there, but they couldn't tell exactly where. When it detonated, then some of the monitoring stations that were international monitoring stations that kept track of potential nuclear test ban, potential nuclear detonations for nuclear tests, detected the shock of the impact. So again, it was an atomic bomb-sized impact. Sometimes you don't like to see them coming at all. There was going to be a near miss in 2013, and this near miss in 2013 was they were watching a meteor that was going to pass by. Then all of a sudden, from the direction out of the sun, so this was in the daytime, this thing slammed to the atmosphere over Russia. And so this is a Russian dash cam picture here. This big flash object flying across the horizon. It exploded sort of over space near several towns, detonated with equivalent force of about 500 kilotons of TNT. So that's like a hydrogen bomb sized impact. and 1,500 people were injured. Okay, so about 4,000 buildings were damaged. A couple completely flattened. Did not get an enormous amount of press attention in the United States. Our media doesn't really cover what happens overseas all that often, but this was a major event right here. 1,500 people injured in one impact. And so in modern times, that is the most people injured. Now, there are instances in which people in ancient times talked about, some devastating event, usually attributed to supernatural sort of things, in which the description is very similar to what you would expect from an impact. And so this is certainly something to be aware of. You know what this means, of course. It means the chicken was right. The sky is falling. And there was a recent atomic bomb impact just a year ago in the Caribbean Sea, just south of Puerto Rico. And so that was another impact right there. Those were all small impacts. Some of these asteroids are big. Remember I said some of them were like 100 kilometers across? Okay. What would that mean? You get some of them that are over 100 kilometers across, and what would happen is that it would come into the atmosphere. It would slow down slightly. It'd be hitting the atmosphere at like 18 or 19 or let's put this in miles per second. It might hit the atmosphere at like 15 miles per second. It would slow down to 14.9 miles per second through action of the atmosphere. It might be, let's put it in the mile size, it might be like 75 miles across. The outer 6 inches of it burn off. Okay, it hits the ocean. It punches through the ocean floor, ocean into the ocean floor, punches through the floor of the ocean, punches through the crust of the earth into the mantle before the top of it is finished entering the atmosphere. Okay, so this is a major impact. Okay, to put this mildly, this would be devastating on a large scale. It would set up a tsunami of unbelievable proportions. An impact of this size into the Atlantic Ocean could conceivably inundate the entire United States east of the Rocky Mountains. So all the way, the entire everything east of the Rocky Mountains could get inundated. Okay, the impact would actually throw so much debris into the atmosphere. You have secondary meteorites raining down across the entire planet. Molten rock falling across the entire planet, setting fires across the entire planet. It would crack the crust of the Earth. It would create a scar, we call an astral that would then create possibly 1,000 years of volcanic activity polluting the atmosphere. You throw so much stuff into the atmosphere that you would blot out the sun for weeks or months at a time. And then all the volcanic activity would be putting things in the atmosphere as well. It would be so hot, it would actually cause the nitrogen in the air to burn. You'd be raining nitric acid across the entire planet. So this is bad. Something like this happened 65 million years ago at the end of the age of the dinosaurs. Okay. Dinosaurs didn't do well with that. Okay. It's not that they all fell over dead. What happened was that it ruined the climate of the planet for so long that things that survived had trouble adapting. Because we're talking about 1,000 or 10,000 year climate change. Massive climate change. Some of these things would actually spall or throw crust material of the earth up to fall down in other places of the earth. In fact, we have samples of this. I've got one I got here at the house, and then we got some samples on campus of actually chunks of the earth, molten blobs of the earth, were thrown out of the atmosphere and fell back someplace else. Okay. Now, this would obviously be a very bad thing to happen. And so astronomers naturally watch out for it. Okay, we're constantly searching the sky looking for things. And so we actually had a project a number of years ago with the students here on campus that were actually searching for asteroids and found several asteroids. None of them that crossed Earth's orbit, but they found several asteroids. The one student did find an asteroid that crosses Mars' orbit. 2004, there was something discovered, 2004 MN4. And initially, when they discovered it, they weren't exactly sure where it was going to go in the future. And so the orbital path was a little bit uncertain. And so they calculated the orbit, but the uncertainty was fairly large and like that. And so the problem was the area of uncertainty crossed Earth. Okay. So this thing would, if it were to hit, would be absolutely devastating. They estimate it could possibly have an impact upwards of 880 megatons of TNT. How big is that? The biggest explosion known on Earth, which actually had major climatological impact that impacted the entire planet, was the explosion of the Krakatoa volcano that was 200 megatons. This would be over 4 to 5 times larger than that. So 1 in 300 chance of this happening. They named the asteroid 99,942 Apophis, after the Egyptian god of destruction. And so later measurements, however, it passed close to Earth again a number of years later. And so later measurements showed that the orbit would miss Earth by a narrow margin. And as it passed by, both Goldstone and Arecibo radio telescopes bounced radar off of it and get an idea of roughly the shape of it up here and the size, about 450 meters. So there it is compared to, for example, the Eiffel Tower and the Sears Tower. So it gives you an idea as to how big this object would be and why we don't want it to actually hit Earth. Okay. The closest approach currently is predicted to be in April of 2029, so just under 9 years from now. It's going to pass within 31,000 kilometers of the Earth's surface. Note this is lower than the geosynchronous satellites. So this will be a very near miss. It will be magnitude 3. So that means it will be visible to the naked eye as it passes overhead. Okay. China actually has a planned flyby, unmanned mission to fly by it in about 2 years. And so, Apophis, it's going to miss us. We're certain it's going to miss us, barely. Okay, it's going to barely miss us, but it will barely miss us. It's not going to be an impact, so don't. If you see something on the internet about it slamming into us, no, it's not. They thought for a while it might have a small chance of it, but they've narrowed the orbit down. I mean, something this close, they've really studied it very, very carefully. So we got the orbit very well measured.